All right. Good day, viewers. We have a question on the board. It's a question on friction under the concept of physics. It says two bodies X and Y of masses 5 kilogram and 7.5 kilogram respectively are connected by a light inextensible string as illustrated in the diagram above. So these are the bodies block X and block Y. The mass of block Y is 7.5, the mass of block X is 5.0. So over here we have the frictional force acting. This is a smooth pulley and this is a rope, and then this is a rough surface. Okay, it goes on to say, they said if X is placed on a rough surface of coefficient of friction 0.5, the coefficient of friction of that surface is 0.5. It says calculate the magnitude of the normal reaction on X. So we'll first take this block X, and by taking that block, you're having something like this. Okay, this is the block X. You calculate the weight of the block acting downwards, that is W equals to mg. The weight of a body is W equals to mg, and the mass of the block is 5 kg. So that's 5 kilogram multiplied by g is 10 meters per second square. If I multiply it now, I have 50 newton. So the weight of this block, W, is equals to 50 newton. So this is the mass of the block is 5 kg. The mass of the block is 5 kg, and then acceleration into gravity is 10 meters per second square. So I put it into this formula, W equals to mg, which is 5 kg times 10 meters per second square. You have the weight as 550 newton. Alright, now the next thing there is to look for the normal reaction. Normal reaction will act at 90 degrees to the surface. So I take this as my normal reaction. Going upwards, I have arrow. Normal reaction. Okay. Now the next thing you take is the upward forces. Upward force equal to downward force. So the upward force there is arrow. The downward force is the weight W. So this means that arrow will be equals to 50 newton. So therefore the normal reaction on X is 50 newton. So we have solved that. The next thing we look for is the frictional force between X and the surface. Frictional force, okay, frictional force between X and the surface. So this is a block X. This block is block X. That is this block X. And this is the surface, the rough surface. This is the rough surface. There is a friction force that will act here. Why? Because first, the tension force is acting on this rope. The tension force is pulling this block this way. So friction force will act opposite the direction of motion. So you have this as your friction force. You have this as the friction force F. And friction force must occur between two surfaces in contact. Mind you, I didn't put it here. That was the wrong positioning in the question. I did not put it here, but I placed it between the block and this rough surface. So friction force must occur between two surfaces in contact. Between two surfaces in contact, you have your friction force. So the surfaces in contact are the rough surface and the bottom of this block X. So that is it. Now, since tension force is acting this way, it is pulling this block this way, friction force will act opposite the direction of motion. Okay. Now we know that coefficient of friction, which is mu, coefficient of friction mu is equals to frictional force over my normal reaction. Okay, coefficient of friction is frictional force over the normal reaction. Now making F subject to formula, I have that F is equal to mu times arrow. So the frictional force F will be equal to coefficient of friction times the normal reaction. So I have F is equals to mu arrow. Okay, and the coefficient of friction was given to us. Said if X is placed on a rough surface of coefficient of friction 0.5. So the coefficient of friction is given as 0.5. So I'll be having, you say, but mu is equals to 0.5. Okay, so the frictional force now will be equals to 0.5 times the normal reaction was 50 Newton. That's 50. So this now will be equals to 0.5 is 1 over 2. As 1 over 2 times 50 will give me 2 here and 1. Half of 50 is 25. This gives me 25 Newton. Okay, so half of 50 is 25. So that will give me 25 Newton. So my frictional force, so therefore, frictional force between X and surface is 25 Newton. Alright, remember how we got it? We got it by using the formula for coefficient of friction. Coefficient of friction is mu equals to F over R. I'm making F subject of formula, you cross multiply this times this, mu times R is what? Mu R. So I'm having that F is equals to 0.5 times 50, which gave me 25 Newton. So my frictional force between X and surface is 25 Newton. Alright. So to calculate the tension in the string, first consider block X, okay, and we'll make use of Newton's second law of motion. Newton's second law of motion now tells us that F is equals to ma. Okay, so permit me to call this F prime. F prime equals to ma. That is Newton's second law of motion. Alright. Okay, so we look at the forces. These are the forces acting. First, come back again to this block X. This is block X. Okay, then we take this one, the force going this way is positive X, and this going like this will be negative X. Okay, so the tension force will be positive and the frictional force will be negative. So I'm having T as positive and then minus F as negative equal to ma. Alright. Okay, so T minus F equals to ma, and the frictional force, remember our frictional force, we solved and we got the frictional force F. We solved it and we got it as 25 Newton. Frictional force F was equal to 25 Newton. So I put it back here. So I'm having that T, this is T minus 25 is equal to ma, and m, the mass of block X, is 5 kg. The mass of block X is 5 kg. Do not forget that. Mass of block X is 5 kg. So I put it here. This is 5 times A. I have what? T minus 25 equal to 5A. Okay, I can call this equation 1. Then I'll then go to block X. Say, consider block Y. Consider block Y. This is block Y. I will extract this diagram out. And consider it in a free body diagram. Now, if you look at this diagram closely, you see that this one has a mass of 7.5 kg. Since it has a mass of 7.5 kg, it will also have a weight. Now look at the weight. Apparently the weight will be taking the weight, acting vertically downwards. You have W equals to mg. So the weight now, W, equals to 7.5 kilogram multiplied by 10 meters per second square. And if I multiply this, I'm having 75 Newton. So the weight of block Y is 75 Newton. Now the next thing I'll look at is this tension force acting here. You know, when we looked at the block X, there was a tension force acting along this surface. We called it T. So this tension force is equal and opposite to this other tension force acting here. So tension force acting along the surface of this rope is the same thing as the one acting along this surface, because it is the same rope that is connected along this smooth pulley. So along the smooth pulley you have a rope and tension force is acting. Now with respect to block X, this is the direction of tension force. But with respect to block Y, the direction of tension force is what? It's going upwards. So we'll take that as the tension force going upwards. Okay. So we know our directions. We know our directions that if your body is coming downwards, it is negative Y. And if it's going upwards, it is positive Y. But in this case, it will change. It will change because this block is connected to a frictionless pulley, a smooth frictionless pulley. So the direction changes. Here becomes negative Y, and this becomes positive Y. Okay. So since it is a smooth frictionless pulley, the direction changes. So coming downwards now, you are taking it as positive Y, and going upwards, you take your direction as negative Y. Okay, so we can also apply Newton's second law of motion there, so that we can obtain the tension acting along that string. Okay, so applying Newton's second law of motion, we have F prime equal to ma. So by applying Newton's second law of motion, you have F prime equals to ma. Now we'll look at the summation of all the forces. And like I said earlier, the one acting downwards, which is the weight, becomes positive. So I'll take the weight acting vertically downwards, positive, and the tension force acting upwards becomes negative. That is minus T. W minus T will be equal to ma. Okay, so we have seen the summation of the forces. F prime shows us summation of forces. First, the one acting vertically downwards is the weight. We took it as positive, and then the one going upwards, we took it as negative. Reason being that for a frictionless pulley, the direction changes. Okay, it is frictionless. So we took the one going upward as negative, and the one coming downward as positive. Alright, and we found the weight. The weight of this block as 75 Newton. So this is 75 minus tension force equal to ma. Okay. Now I can also rewrite this as minus T plus 75 is equal to ma, and the value of m, also remember the value of m is 7.5. The value of m in this case, m here is 7.5. Okay, so this will change. This now will change to 7.5a. That is 7.5a. Okay, in place of this, I'm having 7.5a. I call this one equation 2. Call this equation 2. I'm having minus T plus 75 Newton equal to 7.5a. Call this equation 2. Now I will solve simultaneously. So by solving simultaneously, I'll first write equation 1 out. Equation 1 is T minus 25 equal to 5a. Equation 2 is minus T plus 75 equal to 7.5a. Call this equation 2. Alright. So T minus 25 equal to 5a. And then minus T plus 75 equal to 7.5a. Then I will use elimination method of solving simultaneous equation. Use the elimination method and say equation 1 plus equation 2. So using the elimination method of solving simultaneous equation, this now will be T, that is T plus minus T, and minus 25 plus 75 is equals to 5a plus 7.5a. Alright, and T plus minus T, then plus times minus gives us minus, that is T minus T. Plus times minus is minus. Okay, then I have minus 25 plus 75 equals to 5a plus 7.5a. If I do that, T minus T is 0. This will cancel out this, and then minus 25 plus 75 gives me 50. Okay, this is 50, and then minus 25 plus 75 is 50, 25 plus 75, 50. Then I have 5a plus 7.5a is 12.5a. Okay, I'll then divide both sides by the coefficient of a. And I add this. Divide both sides by the coefficient of a. That means I'm dividing both sides by 12.5. Divide both sides by 12.5. So you have 50 divided by 12.5 is equals to 12.5a divided by 12.5. So this will eliminate this. And then I'll have a will be equal to, and I divide 50 by 12.5, I'll have that a is equals to 4 meters per second square. So when I divide 50 by 12.5, I have what? My acceleration as 4 meters per second square. And I then come back, you say from equation 1. I can use any of the equations. I choose to use equation 1. Equation 1 is t minus 25 equal to 5a. So if I substitute the value of a here, a is which is 4, substitute into this, I'll have t minus 25 equal to 5 times 4. That is t minus 25. 5 times 4 is 20. And then t will be equals to 20. Take this minus 25 over here. We'll have plus 25. So I have that t is equals to 20 plus 25 is 45 newtons. I have my tension force as 45 newton. Okay. So first I found the acceleration using a simultaneous equation. Solving simultaneously, I used the elimination method of simultaneous equation, and then I had to add equation 1 and equation 2. So that is t plus minus t, then minus 25 plus 75. Okay, minus 25 plus 75 equal to 5a plus 7.5a. Okay, so 5a plus 7.5a gave me 12.5a. And you see this plus times minus is minus, so t minus t is 0. Okay, so it will cancel out. The minus 25 plus 75 is 50. So I divided by the coefficient of a. The coefficient of a is 12.5. So divide both sides by 12.5. I have 12.5a divided by 12.5, and it's equivalent to 50 divided by 12.5. This will cancel out this. 50 divided by 12.5 is 4. That is, my acceleration is 4 meters per second square. I come back to equation 1. I can use either equation 1 or equation 2. I choose to use equation 1. That is t minus 25 equals to 5a. I substitute the value of a. The value of a here is what? 4 meters per second square. So I put it there. I substitute the value of a here. In place of this a, I'll write 4 meters per second square. So in place of this, I write 4 meters per second square. I'll be having what? T minus 25 equal to 5 times 4. And 5 times 4 gives me what? 20. Okay? So this is t minus 25 equals to 20. Collecting like terms. This minus 25 will cross over to this other side. Minus 25 crossing over to this side becomes what? Positive. So minus 25 crossing over here becomes plus 25. So 20 plus 25 is what? 45. My tension force is 45 Newton. Alright, thank you. Thank you very much. God bless you.